Excellent. Hello again, everyone. Welcome to today's snow drought and water supply briefing for the Intermountain West region. This briefing is hosted by NOAA's National Integrated Drought Information System, or commonly referred to as NIDIS, and we will be providing the region with timely information on current and developing drought conditions, in addition to providing a forum to hear from experts on the impacts of these conditions. I'm Meredith Muth, the acting coordinator for the Intermountain West Regional Drought Early Warning System at NIDIS, and will be moderating the briefing today. Let's get started. For those unfamiliar with NIDIS, this federal interagency program, hosted by NOAA, was created by Congress with a mandate to help the nation prepare for, mitigate, and respond to the effects of drought. NIDIS does this through a series of activities, including the coordination of regional drought early warning systems, also known as DEWs, and shown on the map here. Information on drought conditions and impacts is shared through the regional DEWs networks, as well as the U.S. drought portal, known as drought.gov. This briefing will focus on the Intermountain West DEWs region, shown in dark blue on the map. Please see the links in the chat box to sign up for the Intermountain West Regional DEWs list to keep up with the latest regional drought updates, webinars, and news. Today's briefing will highlight the unprecedented snow drought in the region and will provide early warning on potential impacts to spring runoff, regional water supply, and wildfire risk. Our first speaker is Dan McEvoy. Dan is a researcher with the Western Regional Climate Center at the Desert Research Institute. Dan will provide an overview of snowpack and drought conditions, as well as outlooks into the spring. Our second speaker is Paul Miller. Paul is a service coordination hydrologist at the NOAA Colorado Basin River Forecast Center. Paul will provide an overview of regional water supply status and forecast. Our third and last speaker is Tim Brown. Tim is a research professor at the Desert Research Institute and is director of the Western Regional Climate Center. Tim will speak briefly about the potential impacts to wildfire activity in the region. I am excited to hear from this excellent group of speakers. Thank you again to all of you for joining us today. A recording of this webinar will be posted on drought.gov. Questions for the speakers will be taken at the end. Please enter your questions anytime using the Q&A function in WebEx. You click the Apps button on the bottom right of your screen, type in your questions, and hit send. Identify when possible if your question is for a specific speaker. Okay, now we'll go ahead and get started with our first speaker, Dan McEvoy. Dan?
Okay, well, great. Thank you so much, Meredith, for having me today and for the introductions. I am going to cover what's going on with the snowpack and briefly describe the overall drought conditions. I'm going to get right into it. As Meredith already mentioned, the bottom line here, there is currently severe snow drought conditions across much of the Intermountain West DEWs region. And on the right-hand side, I have two maps. The map on the left-hand side is our metric of snowpack and snow drought. This is the snow water equivalent. It's the amount of water that's stored in the snowpack, and it's measured at these SNOTEL weather stations all across the western U.S. And the map on the left there is showing the percent of median snowpack right now, or snow water equivalent, through the end of the day yesterday. So through last night at midnight, which includes the storms that have been occurring over the last week. And on this map, the reds and the browns are showing the worst conditions, where you have much below median snow water equivalent. The reds are less than 50%, and the browns are less than 70%. And you see much of the region is covered in those reds and browns. As you move further north, things are a little bit better, particularly in northern parts of Wyoming. So we have this severe snow drought, but if you look on the right, you see the story from what's going on with precipitation for the water year. And so this was beginning October 1st through yesterday, the total accumulated precipitation in each of these basins shown as a percent of median. And the same color scale here, where the reds and browns and yellows are below average, and then the greens and blues are above average. And the main difference here on this map on the right is we don't see any of the reds and we only see browns in a couple basins, indicating that precipitation this year has been close to average in a lot of these basins, or above average in some cases. There have been some areas where it's been quite dry, particularly in central Colorado. Next. And so the key point here, if you can go back one slide, the key point here in some of these basins, like the upper San Juan Basin there in Colorado, 55% of median snowpack and 101% of median precipitation. So something else is driving the snow drought. Next. And really, it's these really warm temperatures that have been occurring this snow season so far. Record warm conditions for many of the western states. This map is from NCEI showing November through January statewide average temperatures. All of the dark reds with the number 1 there are the record warmest in 131 years. So extremely warm during the snow season. And this leads to things like higher rain snow lines during storms, but then we've also had some extended dry spells, particularly in January, where we've seen snow melt, particularly at lower elevations, and even somewhat at higher elevations due to these warmer temperatures. Next. And to further emphasize this point, we've had more rain and less snow in the mountains this season than usual. These are 2 graphics from the North American Freezing Level Tracker. On the left, showing the November through February freezing levels, and then on the right, showing the percent of precipitation falling as snow for a grid cell near Crested Butte on the west slope of Colorado. These are showing trends from 1948 to present. And so the freezing level is the level in the atmosphere where the temperature is 32 Fahrenheit or 0 Celsius, and it's a good rough proxy for the rain snow line. What we see this year is that that freezing level has been greater than 9,000 feet averaged over that time, which is far below the average, which is around 6,500 feet and the highest on record. And then on the right, we see that the percent of precipitation falling at snow at about 6,000 feet at this latitude has been about 30%, and it's typically greater than 50%. Next slide. So all this has translated into record low snow water equivalent across the region. These dots represent those SNOTEL stations that I was talking about. All the red dots are places where the snowpack is the lowest on record. The key thing to note here is that these stations have records that go back to 1980, some of them less than that. And so most of these locations have about 20 to 45 years of data. And in terms of defining this snow drought, there's a basic metric where you look at the snow water equivalent that's less than the 20th percentile or in the bottom 20% of all years. And across the region, about 70% of all those stations are in snow drought right now. Next. And so I wanted to go through a couple of the larger basins and show the evolution of the snowpack through the season. This is for the upper Colorado Basin. This is showing how the snowpack has evolved since October 1. The black line is the SWE for this year. And then the shading is a range of historical values for this basin. And the green is the close to median, or what we see in a typical season. And so this year we're currently in this basin at 68% of median and 48% of that peak median that occurs in about 50 days from now. And so this is the lowest SWE on record in this basin going back to 1986. And the year started off very slowly, and then we had some decent storms, and then there was a long dry spell in January, and things have started to pick back up again. Next. But these recent storms they've helped, but they have been not enough by any means to recover from this snow drought due to the deficits that have accumulated since the beginning of the snow season. Next. And so this is a similar graphic, but now this is showing data from the NRCS that provides projections of what can potentially happen to the snowpack moving forward. And so the black line is the same trace I showed from the previous slide showing the snow water equivalent from this year. And then appended onto that, the red dotted line and the gray shading is showing a likely range of possible scenarios simply based on what's happened historically with the data and how that snow water equivalent has changed in the past. So this is not showing any weather forecast data. It's basically showing the likely range. So about 30 to 70% of the time this scenario will happen, and how that snowpack changes over time. Next. And when we look towards where the peak of the snowpack is for this year, it's looking likely that this year will be far below that historical median and likely below the 30th percentile. Now, if we have an extended wet and cool period, these traces will change and could be higher. And if we have another extended warm and dry period, those values could be much lower than shown in that likely range. Next. So I'm going to show the same couple of graphics now for the Rio Grande Basin, another very important basin for this region. And as of right now, the snow water equivalent is at 49% of the median and just 39% of that median peak shown by the arrow. And it's currently at the 6th percentile. This basin has consistent records going back to 1990. This basin started off really slowly, again, accumulating snowpack, and then had some kind of longer duration, more extended dry spells than the Colorado has had. Next. And we do see that the storms over the past week have had some impact on this basin, and this is all good news to get this snow and water in the snowpack. But again, it's not nearly enough to get close to those median values shown in the green traces and the green shading. Next. And again, these projections now from the NRCS showing some likely ranges without considering the weather or climate forecasts show a similar situation to the Colorado Basin. Next, please. With that likely range of peak SWE ending up far below that historical median, and in this case, even further below than the Colorado Basin, below that 30th percentile. If you follow that red dotted trace, that stays largely below the 10th percentile, so a little bit worse in terms of what the historical data show for the likely outcomes for this basin without considering any of those weather or climate forecasts. Next, please. And so to tie this in to how the drought conditions are depicted, we can look at the U.S. Drought Monitor map that was just released this morning, showing the drought conditions across the region. Any shaded colors indicate either abnormally dry or drought conditions, which is majority of the region here. As of this morning, about 64% of the region was in a drought category. We do have some regions in Colorado showing that worst case scenario of D4 or exceptional drought, and larger areas in severe and extreme drought. And interestingly, you might look at places like central Arizona and see there isn't much drought showing up on that map, despite how poor the snowpack is. And this snowpack can be a lagging indicator of the impacts that show up. And so I really think in places where this snow drought persists throughout the season, which is looking likely for the main river basins, that this map will start to look worse as we get into spring and summer as more drought is introduced. As we don't often see the impacts from the lack of snow until the spring and summer, when we get into water supply and wildfire danger concerns. Next slide. And lastly, I briefly just wanted to touch on looking ahead for the next couple weeks and then the next few months. So the map on the left is showing the 7-day precipitation anomaly forecast from an ensemble from multiple model runs averaged. And so on this map, anything in green is above average precipitation, yellows are below average. And so for the Intermountain West, there isn't a strong signal. There are some indications of near to below average precipitation, and no big storms in that 7-day forecast for sure. And then on the right, looking out into week 2, we see warm conditions returning to the area, favored for most of the area, and then drier conditions coming back to the southern part of the area, and still higher odds for wetter conditions in Wyoming. Next. And then the seasonal outlook, which was also just released this morning for March, April, and May, shows a higher likelihood of drier conditions for that season for most of the Intermountain West Dews region, with a stronger signal in Arizona and New Mexico and parts of southern Colorado. And then on the right, there's higher odds for above normal temperatures for pretty much the whole region, except for the far northern eastern part of Wyoming. Next, I think that was all I had. I wanted to leave these key takeaways up here. Again, this is one of the worst snow droughts in at least the past 40 years for the region. The temperatures have really been one of the key drivers in making this snow drought as severe as it is right now, and it's going to be very difficult for the Colorado and Rio Grande basins to recover at this point. And the peak snowpack will likely be much below normal. So thank you so much.
That was outstanding, Dan. You did an excellent job of telling the snow drought story that has been in so many headlines this past month. We'll now pass it over to Paul Miller from the National Weather Service to provide a regional water supply status and forecast.
Hi, thanks everybody. Hi, I'm Paul Miller. I'm the Service Coordination Hydrologist over at the Colorado Basin River Forecast Center. That's mostly just a fancy way of saying that I'm the outreach person. I work with a lot of our stakeholders to make sure that our products and services are meeting their needs. Next slide. So in that vein, we really are an operational office that's all about stakeholder-driven decision support. We don't make any forecasts in our office that doesn't have a need or a want out there in the broader resource community. Everything we do has a purpose associated with it. We're not just making forecasts for the sake of making forecasts, which I think is really cool. We can really tie our work to the operational decisions being made out there in the world. We're also very much a data consumer. We are so appreciative of all the work that goes on with many of our stakeholders, but a lot of our partners as well, including the USGS and the NRCS, and the efforts that they go through to collect stream flow information and snowpack information. It's just critical to what we do, and we really appreciate all of that. And then we're always trying to develop and improve our forecasting. So whether that's looking at new data sets or new ways of modeling or configuring our model, we're always willing to take a look and investigate ways to go forward with our improving our forecast methodologies. Next slide. So with all that being said, I'm going to reiterate and compliment a lot of what Dan set up for me. So thanks, Dan. But yes, it's been a very dry year so far. Our water year to date precipitation numbers have been well below average. You can see in the Colorado headwaters, we're really in that 60% range for much of the water year so far. And then even looking through the beginning of February so far, and even with these recent rain events, things have been better. But aside from a few locations that are above average, it's generally been dry. You can see the map on the right is showing month-to-date precipitation for the month of February. Again, you can see a few areas with the blues and the greens that are near or above average, but for the most part, we're still well below average throughout many of the significant areas that contribute to our runoff in our basin. Next slide. Kind of switching gears and looking at the state of Utah, again, we're seeing a very similar story. Very dry conditions throughout the start of the water year, with some exceptions for the Duchesne here at the start of February. But for the most part, pretty dry conditions. Again, for the water year, we're below average, kind of hovering in that 70 to 80% of average in most areas. As we get to the lower Colorado River Basin, which is the next slide, you're going to see, again, pretty dry conditions. February in particular has been pretty dry. I want to caution on the use of some of these percentages here. As you might imagine, precipitation amounts in Arizona and the lower Colorado River Basin in general are pretty small. So, recent storm events like the ones we've had and relatively small amounts of precipitation can cause big rises in those precipitation averages. So just to be a little cautious about that. But, again, the story is the same. We're below average, pretty dry, historically dry even in some areas throughout most of the Colorado River Basin and the Great Basin. Next slide. Kind of, again, complementing a lot of what Dan was showing us here. There's a lot of graphs and lines here, but the big takeaway message here is that our snowpack for most of the basin is at near or historically low levels throughout the basin. We've had very low precipitation amounts throughout the basin. And that's been coupled with record warm temperatures throughout much of the West. The period from October through December was some of the warmest on record for states like Utah and Nevada and Arizona and even parts of Colorado. You can look at the graph in the upper right. We saw record warm temperatures throughout much of December. We saw snow melting at lower elevations. We saw rain events at high elevations where typically we would see snowpack accumulation events. So the temperatures were definitely not something to be dismissed throughout this process. We've just seen very dry conditions combined with very warm conditions. Next slide. Again, just kind of hammering home the point that snowpack is very dry and very low. You can see the shaded areas on the plot to the left are modeled snowpack conditions, and then the little squares are the NRCS snow-tell stations. You're seeing lots of reds, oranges, pinks. These are values that are 50% or lower in a lot of areas, typically even hovering in that 30% range. With the exception of being in kind of the upper green area where we see a little bit closer to average, but generally very dry and low snowpack conditions throughout the basin. I wanted to highlight the change in snowpack over the past couple of weeks here as we've started the month of February. We've gotten a lot of interest and questions over the more recent active weather that we've been seeing and how that has impacted our model snowpack amounts. And you can see the first half, the upper half of that table there, you can see not very much, very small changes to our modeled snow water equivalent. This storm just really hasn't had a huge impact. When you look at the Great Basin, similar kind of issues there, generally, basically unchanged snowpack conditions in our model. The lower Colorado River Basin has seen some increases, but again, caution against using those kinds of percentages when we're dealing with pretty small numbers there. The little graphic to the bottom right is from Carl Richter's Snow Today graph, which uses satellite information to look at total snow covered area over the upper Colorado. And that little blue line there is just showing that we're at historically low levels based off of the satellite snow cover data. Next slide. I pulled these really cool graphics off of the NRCS's interactive map page, which I think are really great. The plot to the left shows record low snowpack at particular snow-tell stations. Those are in red. In orange, those are the lowest, second lowest snowpack or snow water equivalent values for the period of record for each of those stations. So again, you're seeing many of these snow-tell stations are showing either the lowest or the second lowest snow water equivalent values over each station's period of record. And you can see just how frequent those are. If you go to that same map and look at where these percentiles typically fall for all of the snow-tell stations for their snow water equivalent amounts, you're basically looking at the bottom 10th percentile for every gauge in our area. I also kind of wanted to highlight the activity over the last couple weeks. We've seen some areas get an inch or two on average. So that's been beneficial. But again, this latest round of storms just hasn't had the impact that maybe some would have hoped. Next slide. How this translates into our water supply forecast, the map to the left shows our water supply forecast points. Again, we would love to be showing you blues and purples and greens, but unfortunately we're at the other end of that color spectrum. A lot of our forecasts are hovering in that 50 to 60% range. Some, kind of getting a little higher than that, but not much. Yeah, it's just been very dry, and with these dry snowpack conditions, which is the primary driver of our water supply forecast. Again, we're not expecting much runoff over the April through July period. We just haven't accumulated the snowpack, so we're expecting to see much below average conditions. I know there's a very, very tiny little table there in the bottom right, but I just wanted to highlight that if you go to our website, our web developer in our office, Cass, he's done some really cool work with this table. You can go and look at how these forecasts are stacking up, and you can have the colors associated with it on the table. And what I really wanted to highlight is that you can look at the far right to see how much our forecasts have gone up over the past day, the past week, and the past month. So you can really see how this recent storm event has been impacting our water supply forecast. The good news is that the recent storm has pushed those water supply forecasts up in a positive direction, but only by 1% or 2% in most situations. So in the right direction, not enough in the right direction, if that's helpful. Next slide. And I think you can click one more time just to get through here. Yeah. So there's a lot of stuff going on this plot, but what I really wanted to have this slide serve as is just a reference on how to read our forecast evolution plots. If you go to our website, basically what we're trying to show you is the entire range, or at least most of that range, of the probabilistic information that that we're trying to convey to our stakeholders. We have some very savvy stakeholders that love to use the probabilistic information. And I think it's also important for us to get the messaging out, just how dire this particular season could be. A lot of times you're going to see our 50% value as our forecast value. That's the value that we're typically associating with a forecast point. That's our 50% value. But if you look at our 90% chance of exceedance value, that's that value at the bottom of that pink line there. That's where we're kind of saying realistically, if things continue to be as dry as they've been, if we continue to be historically dry even, we can be at or even a little bit below these values. And when you're looking at these particular graphics at Blue Mountain Reservoir along the Green Mountain Reservoir around the Blue River, too many colors, you can see there's a chance that we might see some historical dry conditions over this runoff season. A not insignificant chance, even if it's only at that 10% chance, it's still something that is important for our stakeholders to consider. Next slide. This is a shot of our most popular forecast evolution product, the one that is at Lake Powell. What I just wanted to highlight here, you can kind of see on the graphic on the right here, that median forecast value, that 2.4 million acre feet, 38% of the 30-year average spanning from 1991 through 2020. That's what we're currently expecting the runoff to be over that April through July period. I just want to highlight those end points, those extremes at the 10% exceedance forecast and the 90% exceedance forecast. Like Dan was saying, there's a very low chance that we're going to see conditions that even get us close to average. I think looking at very wet conditions, near historically wet conditions, that's the kind of thing that's going to get us up to that 10% exceedance forecast. And even then, we're only hoping for 77% of average at some of our most optimistic forecast amounts. That 90% exceedance forecast, looking at 950,000 acre feet, only 15% of average. That's rivaling the historic min that we've seen at Lake Powell. So again, very dry conditions. This range of possibilities is showing that it's not likely that we're going to get to normal conditions going forward. Next slide. So just to wrap up, our forecasts have a broad range of impacts spanning a lot of different sectors. Folks are making decisions on our forecast every single day, but I wanted to provide an example that I thought was really cool here on the next slide on how some of our partners are using some of this forecast information. I think many folks are familiar with reclamation and using the 24-month study, but I thought this example from Gary Henry, who works with reclamation out of their Provo area office, and how he's using our ensembles and our probabilities was really cool. So the graphic on the far left, the map on the far left, that's a plot showing the reservoirs that he expects to fill over his area of responsibility if we're close to that 90% exceedance value, or that minimum value that we're kind of highlighting on our ensemble graphics. You can see only Hiram Reservoir, which is kind of very tiny near the Utah-Idaho border. That one gets like a maybe, it might fill. If we get sort of that more normal or that 50 percentile forecast, that's that middle map. You can see we get a couple more reservoirs in that maybe category, the yellow ones there. And then you see maybe Kazi and Hiram are expected to fill. But then even if we get to that higher end of our forecast range, we see, starvation might join that list of filling reservoirs. But again, just a whole lot of maybes. And so, Gary's able to look at these, at our ensemble, look at the probabilistic information, and he gets a really good idea on what he's going to be dealing with as far as reservoirs being able to fill this year or not. But I thought this was a really cool example that I'd share with you guys. And I talked to him, he said he's okay with me sharing it too. So next slide. So just to wrap up with some key takeaways here, again, just historically dry conditions are reflected in our water supply forecast. You're seeing very dry conditions expected over that April to July runoff period. The recent storm activity has had really little impact to our snowpack and the water supply forecast over the big picture. We'll take anything we can get at this point, but again, pretty dry conditions. And then I just wanted to highlight that our streamflow forecasts are still important to our stakeholders despite dry conditions. And I think that example that Gary put together on the previous slide is just one such example of that, where they can really get a feel throughout that probabilistic range of what's going to impact them and what kind of season they're setting up for. And with that, I'll conclude and pass it off to the next folks.
Thank you so much, Paul. I really enjoyed hearing about that example of applications of the streamflow forecast to the to reservoir management. I think that's really helpful. So now we're going to shift gears just slightly for a quick perspective on impacts of this year's snowpack to other areas, in particular to wildfire activity. So I'll pass it over to Tim Brown. Thank you, Tim.
All right, thank you. Hello, everyone. Yes, this is a perspective. As mentioned in the introduction, I am director of the Western Regional Climate Center here in snowy Reno, Nevada today, but also work very closely with wildland fire management agencies on a variety of topics, and so have attempted here to put some thoughts together for you. So on the next slide, is the official seasonal outlooks that predictive services do. This is the significant wildland fire potential. They do 4-month outlooks. I'm just showing you February and March for now. So a couple things to note. For much of the Intermountain West right now, it's white, meaning that there's really not much activity going on. But notice for some of the area, that's in red and extends into Texas and Oklahoma and some of the plains regions. Potential is very high right now, and in fact, you've probably been seeing in the news fires, especially in Oklahoma and some other areas. And the reason for that is on the next slide, this is just an example of photo of grassland. And so when we think about fire, there's grass, shrub, and timber, call those heavy fuels. So those are the 3 primary fuel types to think about. But grass like this carries fire very well. And so one of the things that a lack of snow will have is not compacting the grass to make it lie flat. If it stands vertically, it's a lot of grass that's kind of this continuous fuel bed across miles and miles. If an ignition begins in there and you have hot, dry, windy conditions, that will carry that fire. And that's what we're seeing currently in some of these parts, even in the middle of February. So a way I like to think about this is climate enables fire and weather drives fire. So I'm just going to jump ahead to some talking points here on this next slide. First of all, it's important to think about how snow is a factor in determining how much compaction occurs, particularly for the grasses. But late winter and through spring precipitation is also a factor in determining how much additional fuels will grow. So drought can really work both ways for potential fire conditions. Now, it's real easy to think that if you've got less snowpack, that there could be very substantial, significant fire conditions later in the season. And yes, that is a possibility. This is the time of year that a lot of folks are asking, hey, what's going to happen later this summer? And gosh, I wish we had a really good answer for that. But part of the difficulties with that is even though you have lack of, say, snowpack in the higher elevations, now thinking about forested regions, or you have early timing of snowmelt, in reality, that may or may not be impactful for the next season. It probably tilts a little bit more to be impactful, but it really comes down to then what happens in between that snowpack, the runoff, and then when the fire season really kicks in. So the timing and the extent of the spring green up, this also impacts. If there are wet events going into the spring, maybe rain, that will keep the fuels moistened. Even if the heavier fuels, like the forested areas are drought stressed, the spring precipitation could still help that, even into early summer. And of course, in the Southwest, the monsoon is a factor, as well. And also further up into the Intermountain West region. So the snowpack can definitely drought stress the vegetation, from the reduced soil moisture. There may also be a feedback process where that drought stress also increases the atmospheric drying, either looking at that through something like vapor pressure deficit or evaporative demand concepts. So there could be a feedback process here as well that exacerbates what the fire outcome might look like. I talked to a few folks about what the upcoming season might look like. I think there's an expectation that on those significant outlook maps, we are going to see a lot of these areas turn red as we get further into the season, unless there's some kind of major switch in circulation pattern that keeps things cool and moist. But as you heard in the previous two presentations and the CPC seasonal outlook, it's really not obvious right now that there's going to be a lot there to do that, but we're just going to have to wait and see. And one final impact about a reduced snowpack is how it might limit prescribed fire activity. And this is where agencies go out and conduct controlled fire for a variety of reasons, hazardous fuel reduction or ecosystem habitat, health improvements, those sorts of things. If conditions are much drier, the underlying conditions, and then it's also warm on top of that, and we've heard that it's been a very warm winter, that's going to reduce the amount of prescribed fire activity, and then that in turn could also help increase the fire potential as we get more into the summer season. So I think those are the highlights for now, and just short of what we know at this point for the potential for the wildfire season.
Thank you, Tim. I know there's a lot of concern about these impacts to wildfire season, and I appreciate you highlighting the complexity. Okay, so now we are at our question and answer time period. Just a reminder that you can enter your questions in the Q&A function in the WebEx portal. Just go to your bottom right, click the apps button, type in your question and hit send. Before we get started with our questions, just one more thank you to our excellent speakers today, Dan, Paul, and Tim. They will now take your questions. Okay, my first question is going to be, I think I'll direct this to any of you that would like to answer. This is about El Nino. Do the projections and outlooks that we discussed today include the potential for an expected El Nino event?
So I can take that. The short answer is no. We've done a lot of analysis looking at El Nino and different El Nino indices, or El Nino related indices, I guess it might be a better term, and how they might correlate with our forecast. We've noticed some correlation with water supply forecasts in the Arizona area. But what we found operationally is that in using those forecasts, it can really push forecasts too far in one direction or another. The forecast will really want to hang on to that ENSO signal in one direction or another. So we've just found it more beneficial to use our ESP model. It seems to be more skillful year to year when we're doing that. But so yeah, we don't really incorporate those indices into our forecast.
That's great. Thank you, Paul. This next question I'm going to direct to Dan. What would you say is the primary driver of the snow drought? You did mention quite a few times the influence of the warm temperatures, the record-breaking warm temperatures. Would you like to expand on that?
Yeah, the extreme warmth and the record-breaking temperatures have been a major driver and contributing factor to the snow drought this year. And the low levels of snowpack that we're seeing would not be possible in some cases without the temperatures being that warm. Now, as Paul showed a bit more than I did, there are areas that have had low precipitation as well. But when you look at this across the whole season, if we had average temperatures, even the snow drought would not be as severe. So it is a key driver of the severity of the snow drought this season so far.
Great, thank you very much, Dan. Paul, I'm going to direct the next question for you. This is related to Lake Powell. Are we on track for the lowest April to July runoff into Powell? What is the lowest on record now, and when was that?
So it's tough for me to say that we're on track for the lowest runoff into Lake Powell. So if you, I don't know if it's easy to go back to, I think it's my 11th slide. You can see what the historic min over our 30-year period, and I'm pretty sure this is the historical min also, but back in 2002 when we only got, I think it was like 20% runoff. So I would say if we continued to have a historically dry spring, I think it's possible we could reach those levels, but I don't think it's fair to say that we're on track to get there. You can see based off our spread that there's probably over a 90% chance that we're going to get something in excess of that historic min. So I don't know if I'd be so strong as to say that we're on track to see a historic low. Right now our 50th percentile forecast is for 2.4 million acre feet. That's 38% of average, which is still a good amount higher than that historical low. But yeah, I don't want to downplay it either. These are pretty low, pretty dry forecasts.
Great, thank you, Paul. The next question I am going to send over to Dan. This is related to monitoring networks for Snowpack. So this is from someone who lives in northwest Wyoming, where snow water equivalent is in about the 90 percentile range, but low elevations seem much lower than that. Is there any monitoring or good data sources for low elevation snowpack? And how is lower elevation snowpack factored into water supply forecast? So that second part of the question I'll direct over to Paul. Dan?
Okay, yeah, that's a really great question. And I didn't touch on it too much, but Wyoming is one of the places, as well as other parts of the region, Utah especially, where there is an elevation gradient in the percent of average snowpack right now. So as the whoever asked the question mentioned, at higher elevations, you might have a 90th percentile snowpack in parts of northwest Wyoming, but then down lower, even where we have snow-tell stations, which is usually still in the middle elevation range in the mountains or lower, but not in the valleys, those snowpack numbers are much lower. Then you get down into the lower valley locations, and snow-tells don't exist at those elevations. So there are some data sets out there. One of the ones that we've been looking at, and I believe Paul might have showed one of the graphics, was satellite-based snow-covered area is a good thing to look at. That can basically tell you where there is snow and where there isn't, and in a typical year where there should be snow based on the satellite era data. And there's also cooperative observer networks that manually measure snowfall and snow depth in valley locations. And so those types of data can also be really helpful to get a better picture of the snow conditions in valley locations. But it's a big challenge because we have hardly any snow water equivalent data in those valley locations other than what comes out of models, which can often have biases one way or the other. So it is a big challenge, and I think that's a good segue into the water supply part of the question. So I'll turn it over to Paul for that.
Thanks, and sorry, could you repeat what my part of the question was?
Yeah, absolutely. So how is lower elevation snowpack factored into water supply forecast?
Yeah, that's a great question. So our model is a conceptual model, and we divide each of our forecast points into elevation zones. So there's a lower elevation zone, and then possibly, a middle or a high elevation zone also associated with that. So we're definitely monitoring those low elevation snowpack areas. I would say those areas typically aren't the big contributors to the seasonal runoff. That snow typically, obviously it's the snow that melts first, usually, and can sometimes even melt before the April through July period. But we do have that in our model. We're looking at it, and we do account for it.
That's great. Thank you. And it was an excellent question. I appreciate that. We have time for two more questions. The first question is one that I believe Paul and Dan actually hit on, but it's on a lot of folks' minds. I'm here in Colorado. Everyone was so excited about the snowfall this week, and that's expected next week. Um, Lots of people ready to go skiing. But the question is, how much did yesterday and today's snowfall help at least parts of the region? So maybe I'll direct that to Paul and or Dan.
Sure. We update our water supply forecasts every day, taking into account the latest snowpack amounts and even the forecast for the next 7 days. And I guess the answer is it hasn't impacted things very much. There's been very modest, very slight improvements, only a percentage point or two at most areas. Some of the bigger gains have been in the lower Colorado River Basin region, where there's been virtually no snowpack. So, it's been beneficial more down there. But in the upper Colorado region, in Utah, it's been very minimally beneficial.
Okay, great. Um, our last question. This is looking into the future, but way ahead of the future. And I'm not quite sure if anyone on this call is ready to talk about it, but I think it's a valid question given current climate projections. How typical will these sorts of conditions be in future winters in the Intermountain West over the next decade or so? So maybe I'll start with Dan. Do you have any response to that question about what we could expect over the next couple of decades?
Yeah, I mean, generally speaking, based on what these projections show, we would expect to see more of these types of winters. And the biggest signal that stands out is the continued rise in temperatures throughout the year and throughout the winter. And so there's variations depending on what models you look at in terms of the magnitude and scenarios in those climate projections, but they all show a continued warming of our climate. And so, as we all sort of alluded to this in this briefing, the warm temperatures were not a small factor at all in this snow drought. And so I think if we continue to see this warming, we would expect to see more years like this going into the future. And I think we first saw something like this going all the way back to the 2015 snow drought. That was more impactful in the Pacific Northwest, but that was also an extremely warm situation. And, even back then, looking at projections going, should we expect to see more of this? The big question is, when is this going to start impacting higher elevations in places like the Rockies? And this year, we did see those impacts at higher elevations.
Okay, thank you. All right, so with that, we'll end our Q&A time. Again, so many thanks to all of you who asked questions, attended today, and to our presenters for sharing their knowledge and expertise. a just reminder, if you'd like to continue receiving regional drought information, please sign up for the Intermountain West DEWS email listserv. You can use the QR code or click on the link in the chat. One last thank you to everyone. Before we close our briefing today, I have a few quick announcements. A reminder that a recording and webinar recap will be emailed and posted on drought.gov shortly. If you are interested in additional information at the state level or at the local level, we have some links in chat for you to explore drought information for your locality on drought.gov. And finally, please take a moment to complete a short post-webinar survey that will pop up once you close the webinar. This will help NIDIS and our partners improve our delivery of drought information to the region through the Intermountain West DEWS. This briefing is now concluded. Thank you again for joining us today, and we hope to see you again in future NIDIS briefings and webinars.